Welcome back, our viewers. Today we want to look at sequence and the series, whether we are able to move to this part of mathematics. Now, in sequence and the series, we shall start with a certain pattern, and now we want to consider a pattern of this order. Let's first consider the order of, we are using 3, 6, 9, 12. Look at that pattern, and also consider this pattern. I can interchange and say, if it was starting from 15, 12, then we have 9, we have 6, we have 3, it can continue like that. Look at the first pattern and then the second pattern. What are you seeing for the first and the second pattern? You can see that they are following a certain order, that this is the first number. But when you go to the second number, you can see we have just added 3, and to this other 6 to 9 we have added 3, and the same happens to this other part there, plus 3. This also happens that from 15 to 12, we have just subtracted negative 3, we have subtracted negative 3 to get 9, and we have subtracted negative 3 to get 6, minus 3, we can get 3 there. So what are you seeing here? I'm not looking at more of the value, but I'm looking at more of the sign. The sign here is an addition, this one is a subtraction. And I want to consider a pattern now, the sequence whereby we are either adding or subtracting a constant number. So we are adding, for our case here, we are adding 3 or we are subtracting 3. At the same time, you can as well have a positive 2 on each case, or a minus 2, that case. But I've just chosen that positive 3. I want to look at this sequence, and therefore my part here is on sequencing. Now, what is common with this sequence? We have seen that what's common is that both of them have either addition or subtraction. Now, I want to, the second part. Let me just concentrate on the first part so that I can show what I want to deal with today. Now, if a pattern is following this order of addition of a constant or subtraction of a constant, then that pattern we call it an arithmetic pattern, known as an arithmetic pattern or sequence, known as an arithmetic pattern or sequence. So for our case, we have tried to write as our 3, 6, 9, 12. It can continue like that. Now, this first number here, we call it as our first term. We call it as our first term there. This is the second term, third term, fourth term, continuous like that. Now, therefore, this first term will be represented for our case as our A. We represented by letter A. And what have we seen? We have seen that we always add a plus 3 to get the next number. Now, therefore, this one, we shall call this 3, we shall call it a common difference. We shall call it a common difference. What's a common difference? To find the common difference is the second term minus the first term. For our case, our second term is 3 minus 6, minus 3, which you get as 3. Or you can say the third minus second. Third here is 9 minus 6, we will get 3. So our common difference is that. Notice that we are saying the second minus the first, not the other way around. That's the case we have there. Now, I may want to know. Now you can see I've seen 1, the first, second, third, fourth. I may want to know either the 5th, the 6th, or the 7th. I may want to know what term, the terms that are on that other positions. Now in front there. Now I want to start. If you want to find the 5th term here, of course I will add 12 plus 3, I get 15. To get the next one, I get 18. My question now is, how can I find a number that is very far away from these, the ones that are close to the first numbers that I have here? Therefore, I want to use a formula for you to find a number that is what we call now the nth term of n position, we shall use this formula n a in plus n minus 1 times d. So it will be, they find the nth term. To find the nth term of this arithmetic pattern, then we shall use a plus n minus 1 then times g. That's how we want to find. Now let's use it. For example, our case here. We have our case being number, this is the 50. Let us talk about the 50 term here. The 50 term. 50 term we have said our a is 3 plus our n is 50. Now if it's 50, then I write 5 minus the 1, and it's constant there, then times d. D we have gotten as a positive 3. We multiply plus 3. So what do we get? 3 plus this 5 minus 1 is 4 times 3, which is 12. So 3 plus 12, you get what? 15. And we can see that is 15. And therefore, if I'm asked if the 21st term there, I can easily find it. How can I find it? I just use the formula a, which is 3. I have 3 here. Then plus into 21st minus what? Minus the first one times d. D which is what? 3. And therefore I will have what? I will have 3 plus. This one is 20 times 3 is 60. 60. And that one becomes 63. And that's how you can find the term. That's a formula that you can have. Now that is what they call a sequencing. So therefore we can able to find the term. Let's look at another thing here of now the series. But I'm going to consider the same pattern. Let me consider the same pattern here that we have written. The pattern we have is the 3, 6, 9, and 12, etc. Now let me consider this, but here now I talk about, now consider a pattern, now we talk about a series, now series. So that we define what's a series. A series now will be the form, this pattern here, it is 12, then followed other numbers. And you want to consider this pattern. If I want to find the series simply means the sum of the numbers you have. I may want to find the sum of the first 1, 2, 3, 4, the first 4 terms. I may want to find the sum of the first 4 terms, and therefore that becomes a series. If it's being a series, we can call it now arithmetic. We call it an arithmetic series or a arithmetic progression. We can call it arithmetic series or arithmetic progression if I'm asked to find the sum. Because it's an arithmetic, because we found that we are either adding or subtracting. That's for our case here, we are adding a constant 3. Arithmetic series. Now, to find the sum of this one, is just you have sum of the first 4. We are adding 3 plus 6 plus 9 plus 12. So you can find as this 3 plus 6 is 9, 9 plus 9 is 18, plus 12 is 30. So we have the sum of the first 4 terms is 30. Question now is, how can I find the sum of the first 21? If I'm asking to find the sum of the first 21 terms, you see I already have 4. So I need to have the other remaining around 17 of them before I start adding. You can see that it will be tedious and hectic. Therefore, we want to bring what we call a formula for that, which we write the sum. The sum of those terms that you require is n over 2a plus n minus 1 times d. And by doing that way, you are able to find the sum of whatever you are looking for. Our example here, 4. Let us look at example S4. So n is 4 over 2, then 2a. A is 3 times 2 is 6, plus n is 4, 4 minus 1 is 3. 4 minus 1 is 3, times d. D, our case was 6 minus 3 is 3. What do we get? here is we get 4 divided by 2 is 2, then 6 plus 9. What do we get? We get as 2 times what? This plus this is 9 plus 6 plus 9 is 15, and therefore that sum gives the sum as 30. That's what we got for our case here. If I was looking for the first 21 terms, just write 21, of course 21 over 2 brackets 2 times a, but a is 3, 2 times 3, then plus 21 minus 1 times d, d is 3, d is 3. Therefore, I will continue to get this one. 3 times 2 times 3 is 6 plus 20 times 3. That's what we have there. Then we proceed as 21 over 2 into, this is 60 plus 3 is 60 and plus 6. This 20 times 3 is 60 plus this is 66. Then you have 1, this is 1, this is 33. Then 21 times 33, you get 3, 6, you get 693. So the answer there is 693. That's what you can able to find. And that's what we call an arithmetic series and the sequence that we have looked at. So you can easily find by using the formulas. Now I want to note to write something else, to add something slightly on this series. This series, you can use also this formula. If you are given the first and the last term, you can find this formula. Sn, you can be given as n over 2. The way we did is a plus last term. If you are given the last term, then you apply this formula. So this formula is S. Let us consider our values here. This one is the fourth, and we have 12 there. That's our last term. So the first sum of the first 4 is 4 over 2 into a is 3, then plus what you have is 12. That's our last term. So you find that this is 2 into 15. Therefore, the answer is that, and this is what we add here. Sum of the first 4 terms. So you can use those formulas to easily work out those questions given. Now, after we have looked at the arithmetic series, sequence and series, we move to the next part of the geometric. Let's look at geometric. We consider now where cases, a case where we have either multiplication, or division. Let's consider this sequence. We consider 2, 4, 8, 16, and the rest. So, for you to find, the next time you can see, it's not addition, it's not arithmetic, it's now geometric, whereby we are multiplying. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. It's the same way you can be given 32, for example, 16, 8, 4. Just this one is for decreasing and this one is for increasing. It's the same thing, so I'm using the same way, same method, because here it is 2 divided by 2, divided by 2, divided by 2. So for this other part here is times 2, this one is times 2, this one is times 2. Now, what I'm trying to say, this is now on geometric. Geometric sequence. And geometric sequence is the order now whereby we have a multiplication or a division. Let's consider the first case where we have a multiplication of 2. Our 2 remains still our first term, which we shall still call our A. We have 4, we have 8, and we have 16. Now, this one does not have a common difference, but we have now a common ratio. So here we shall have what we call, instead of common difference, we have now a common ratio, which we shall use as our I. How do you find the common ratio? It will be second over the first. Or the same as you can find third over the second. That is the common ratio. For our case, second is 4, divided by 2. You get as value of 2 now. You get our value of 2 over 2. For the other case where we had 16, 8, 4, our common ratio becomes here 8 divided by 16. Because second over the first, which is half. It is half 1 over 2. Let's now continue for this. Let's continue where our common ratio is. Question is, how do I find the term here? This one is the first, second, third, fourth, fifth. How can I find 50? Of course, I will multiply by 2 and I will get as my 32. You see, I don't know 32 there. At the same time, we can use a formula and to find the nth term of that geometric sequence. It is by using the formula Rn minus 1. Rn minus 1. And let us apply our case here. We ask ourselves the fifth term. What do we get? Fifth term is A is 2, you can see. R, common ratio we have found as 2. So this is 2. Then fifth, this n is 5 minus 1. So it will be 2 into 2 power 4. 2 power 4 is what? Is 16. And therefore we get as 16 times 2 we get 32. And this the 32 we have here. So that if you are asked, for example, 21st term, you can simply get as your A becoming 2, your R becoming 2, then 21st minus 21 minus 1, you get as 22 power 20. This one is 2, this one is 2 power 20. And you know, when pencils are the same as in multiplication, you can add the powers. So therefore 2, the pencils are the same, 1 plus 20 is 21. So the answer, you can write it in power form as 2 power 21. So that is how you can easily find it. Now, we now look at also, now that we have found, we can find the nth term, we now move to finding a series. Let us look at its series now. It is series. What do you get when you talk about a series of this? Series of this. Series. So it is geometric series. And I've said geometric series is just progression. Just progression, which sometimes we get as our TP. Now, let's look at that one. The sum of the first 4. You see this 2, 4, 8, 16. Then we have the other one. Let us find the sum of the first 4. Sum of the first 4 terms there. So what do you get? The sum of the first 4 is 2 plus 4 plus 8 plus 16. 2 plus 4 is 6 plus 8 is 16. Sorry, 2 plus 4 is 6, 6 plus 8 is 14, plus 16 is 30. So you have as you are 30. Now, instead of adding like that, you can as well use a formula. You use a formula for Sn. Let me write the general formula for that. It is Rn minus 1 over R minus 1. Let us apply that formula and see whether it's giving us the same answer as this one. Now, S4, then A. What's A? Our A is 2. Then R. What's R? Our R, you say, is 4 divided by 2, which is 2 power 4 minus 1. Then over R is 2 minus 1. What do you get? 2 into 2 plus 4 is 2 power 4 is 16 minus 1 over, that is 1. 2 minus 1 is 1. So we have become 2 into 16 minus 1 is 15. 15 times 2 is 30. So that's what you already have there. That's what you already have there. why am I insisting on this formula is because you can find the 21st term, any the sum of the first 21 terms or the sum of the first 30 terms. It becomes easier when you are doing the sum of a large pattern, a long pattern, which you can easily find using that one. I want to also note that, to write this, that this is the formula we have for the general. At the same time, you can have a sister. You have a sister of that formula. A sister of that formula is, instead of having a sequence of that, of increasing, we can have a sequence that is decreasing. Like the one we said, 32, 16, 8, 4. If the sequence is decreasing, then for example, I say 16, 16, 8, then followed by 4, 2, you continue. Now, if this is the sequence that you are using, you can apply the same system, this formula, which now we just interchange 1 minus I power n into bracket or over 1 minus I, and that's what you can apply and get that one. So that if you're asked to find the sum of this one, the first 4 still you can easily find using this formula, where you can say, now for our case, you can see R, what's R? R is 8 divided by 16, which is R, and this is always less than 1, this number less than 1. And therefore, if the sequence is that or decreasing, then you can apply that one. Or instead, you can use this one, but you will get the same, but you be very careful when you're writing on the signs, on the negative, dividing the negative signs, and that's what you can find on the geometric series on this pattern. So that is it. That's the simpler way of doing. Instead of adding the values, you can simply use the formulas that we have said. Let us look at what have we said. We have just said the following, so that this one you are able to take into your book, so that you are able to write, be able to apply it where you are needed. So generally, what are we saying? We have said for the sequence, we have either arithmetic, or we have geometric. For arithmetic, the n term is given by, when the n term is a plus n minus 1 d. For geometric, what have we said? For geometric, we have said it is the nth term is a r n minus 1. That's what we have said. Then we have said for this series, for the series, then we have either, we're talking about number 1, arithmetic, or number 2, we are talking about geometric. What we are trying to talk about, right here, geometric. And this geometric, what have we said? Under arithmetic, we have said the formula for that one is Sn equals to n over 2 into 2a plus n minus 1 d, close the bracket. But for this one, geometric, which is our number 2, we have said it is Sn equals to a into r n minus 1 over r minus 1. But we also said this you can also use even the last term you can find as a plus n last term. And this one we said if the sequence is decreasing, you can Sn it is a into rn minus 1 minus r power n, then over 1 minus r. So that's what you can have there. And that's the general formulas you can apply to get your answer instead of adding or making it work tedious. Thank you, and that is the sequence and the series for today.